So I want to go through the 2022 question 1 of the practical paper. So in the question 1, we are given a spring. We are asked to investigate the density of the wire using used to make the spring. Okay, so we are given a spring, of course, 30 centimeter ruler, and a card displaying the mass of the spring. So for simplicity's sake, let me put the mass of the spring to be 20 gram. Okay, so we are given that the spring is made of a piece of wire that's wrapped around a cylinder, and of course, example of a spring, right? Along this length, there is about 21 turns, and 2 turns are at the end. So for example, 2 and 2 right here. So this makes 25 turns in total. So the spring we have been provided is different from the one. So for part A, hold the spring so that there's no gap between the turns, right? Then we are asked to measure the length L, right, and the diameter D with the 30 centimeter ruler. So of course, these are just hypothetical numbers. So for me, right, I will first do the repeating of the measurement. For example, L1, I put 5.0. Just remember, because you're using a meter rule or 30 centimeter ruler, right, you must follow the precision of the meter rule, meaning the 0.1, right? So okay, for example, L1 is 5.0, L2 is 5.2. Then you get the average. When you get the average, I remember to write down this bracket, and then just put L1 plus L2, which is 5.0 plus 5.2, right? Divide by 2. So this will give you 5.1. Just remember the average length or the average timing. You follow the precision of your instrument. Yeah, of course, you can also use another idea is the least least dp rule. For example, right, 5.0 plus 5.2, because it's a plus, it's an addition, right? You follow the least dp, meaning you can actually put like that. For example, 5 is 10, right? So 1 dp, so my answer must be 1 dp, so it's 10.2. Then you divide by 2. So of course you can see, right, this is 3 sf, this is 1 sf. So of course division we follow the least sf, but since 2 is a constant, so constant we do not follow the sf a constant, we follow the sf of the data. So that's why you will still get 5.1 centimeter. Yeah, so you can use this idea to calculate the average. Okay, likewise, D1, I also put 2.0 for example, just hypothetical situation. D2 is 2.2, then you get the average, so it's about 2.1 centimeter. Okay, so this is using the 30 centimeter ruler to measure both your L and D, which is a bit weird because D we normally don't use a 30 centimeter ruler, right? Okay, the next part is this. Okay, we are given a card. So there's a number there, so not 4D number, it's just a number of the mass of the spring, which is about 20 gram, for example. Then we are asked to count the number of turns along length L. So for me, I just write 21. Total number of N of turns, big N in your spring, right? You need to add 2 and 2. The ends, right? So it's about 25. Okay, now here comes the part C already. Okay, part C, we are given many formulas. For example, we are asked to determine the diameter of the wire using the equation. So, okay, the diameter of wire, because the spring is made of thin wires, metal wires, right? So, which is very thin. So, they want us to determine what is this diameter. And this diameter is known to be your small d. Okay, so length divided by n. And what is length? Length is actually the thing that we actually recorded just now. So it's around here. And then after that, divide by n, right? Small n, which is this number right here. So just divide. So definitely 5.1 divided by 21. Just remember this one, we follow the SF of the data, meaning 2SF. Because 21 I would say is a constant. So we don't follow constant. So for this, right, I put 2SF to be as such. So it's about 0.24 centimeter. Okay, for part D, we are asked to determine the length, the total length of the wire. Meaning, if I unstretch all the wires, right, what is the total length? Okay, so the formula is given as such. Big N, which is 25, times pi times small d. Small d, if you remember, is actually the diameter of this. So it's this part. So this is your small d. So which I mean just 2.1 centimeter. So I just put 2.1. So obviously you can see 25 times pi, right, times 2.1. So what is the number of SF I must give them, right, is 2 SF. Of course, multiplication, they can add in one more. So you can give 2 or 3 SF. So for me, I put 2 SF. So it's about 160. Of course, don't forget to write down the units, centimeter. Okay, then after that you will notice one thing. Oh, the volume of the wire. So the volume of wire is given to be as such. L divided by 4 pi d square. So L divided by 4 pi d square. So L 160. Then the D, right, the big D is this part, 0.24. So everything will be constant except 160 and 0.24. So obviously I'm following the 2SF. Because 4 and pi is a constant, so we don't follow SF. So it's about 7.2 cm cube. Always remember the units as well. Okay, then before I go to the density of the wire, which is mass divided by volume, if you recognize one thing is that the volume of the wire, right, is actually include the L right here. So means include the big N, the pi, and of course the D, which is the so-called the spring, right? So for example, I draw the spring again. I draw a spring. So this is, okay, I just draw this. Then after that, this is the D. So this volume include the small d. So obviously, we use a ruler, a 30cm ruler to measure this small d, right? So there is something wrong with this. Okay, now I go to the part 3, the density of the wire using the equation, right? So we are given another equation. M divided by V. M is the constant, the thing that they give us, 20 gram right here. It's on the card lah. Then after that, V is the part 2 answer. So I do the calculation. So 20 is also a constant, so we don't follow. We follow the 7.2, which is 2SF. So means because divide, right, follow the least SF. So this must be 2SF or 3 lah. You can add one more. Okay, so the density is about 2.8 gram per cm cube. Okay, here comes the question that I actually want to talk about. Describe one source of error in the experimental procedure and of course explain how this error affect the calculated value of your density. Okay, the source of error, you can see that is due to the fact that I actually measure the D using a ruler, 30cm ruler. So it's very hard to actually determine where exactly is the diameter of the ruler. For example, I draw the cross-sectional area, the cross-sectional of this spring, right? So it's very hard to determine, where exactly is the diameter, right? So it can be here, can also be here, right? So this will actually affect the result of the V, which will affect the result of the density of the spring, of the wire in the spring. So okay, I write down the source of error. The source of error is that 30cm ruler is used to measure the diameter, small d, right, of the spring. Okay, so that's the source of error. Okay, what is the effect on calculated value of rho? Okay, so for example, right, there's a high chance is that my d, right, the small d, right, I mean the diameter of the spring will be lesser than the actual value. Hence, this will actually cause my density of the wire in the spring to be more than usual. So for example, right, if I look at here, so for example, okay, so you can see, right, so rho is equal to mass over volume. So volume, right, volume is given to be L, L over 4 pi d square. So if I say my d, right, my so-called small d is lower, means that L will be lower. Meaning that my L right here will be lower. When I calculate the volume will not be the actual one, it will be smaller than the actual, which will cause the density to be greater. So that's how we actually do this type of question. So always go back to the practical. So the effect on calculated value of rho, right, or the density is that the L, so not the L, the small d, right, is smaller, means that this will actually cause the big L to be bigger, which will cause the V to be bigger as well. So if the V is bigger, right, the volume of the thing is bigger, so rho equal to M divided by V. So mass normally is quite accurate because it's given on the card, right? Then the V will be greater, means that the density of this spring will be lower than usual. So that is how we normally do this type of question.